All right, so these 6 problems that you have here, these are all salts that are in water, and you're trying to figure out whether or not the solution is going to be acidic, basic, or neutral. And you want to go back and review that very, very last slide in the notes that we completed today, which gave you the rules for how to tell. And first thing you want to do is you want to look at your salt and break it up into the 2 ions that it came from. So here we have potassium, which is K plus. You have your perchlorate over here, which is ClO4 negative. And if you take a look at your K plus, first of all, you know that this one over here is on our list of the ones that came from a strong base. And if you were to just add on the hydroxide over it to you here, you should recognize that potassium hydroxide is on our strong base category. And then for here, if you were to add on our H in the front of your perchlorate, you could recognize this one as a strong acid. So this is my strong base. Here you have a strong acid, and because of that, and if you're taking a look at what the conjugates are going to look like, so my KOH to my K plus and the HClO4 to the ClO4 minus, these conjugates here are both going to be weak. So you have a weak acid here, and then my perchlorate, my ClO4 negative, is going to function as a weak base. And because you know they're both weak, you know that they're not going to have any reaction with water. So thus, we could figure out that this right here is going to be a neutral solution. Now, for my second one over here, we could see how this is going to break up like this. My Na is going to turn into a Na plus, and then it's going to break up into my negative charge here. And you could see that again, my sodium, my Na plus, is one of the ones on the list that came from a strong base. And then here, if we're going to just add on a hydrogen to this, we could recognize that with the hydrogen here that this is going to be a weak acid. This one over here was my strong base. And if you have those labeled out, looking back at our actual conjugates, you know that this one over here is going to be a strong acid. And my strong base is going to be strong base here. And then this side over here from my NaOH, my cation of that is going to be forming a weak acid. So the weak acid we could just cross out and ignore. And because we know we're dealing with something that is a strong base, we know that this solution over here is going to be basic. Looking over here as well, you could break this up into the ions. Again, we have chromium plus 3. Here we have nitrate with a -1 charge. And the nitrate, you know that when it has a hydrogen in the front, this over here was on our list of a strong acid. So I know that my nitrate, my NO3, it is going to form a weak conjugate base. So we're going to just write weak base here. And then my chromium with the +3 charge. This one we actually didn't talk about in class, but the metals could actually form complexes with the H2O to function as here, and I'm not going to actually write it down, but it would look something like this with the +3 charge. And again, we didn't talk about this one in class, but this one over here could be a weak base. And because you have a weak base here, I know that this originated from a strong acid. And once you guys have that, so the weak base we could ignore, and I know that this solution over here is going to be acidic. Okay. Moving down, we could do the same thing, my K plus, This is ClO2 negative. If you were to look at this, I know that KOH was my strong base. My HClO2 is, we know that is not on the strong acid category. So you could tell from number 1 to number 4, dropping the oxygen number from 4 all the way to 2 changes that up, because my ClO2 with the hydrogen in the front, it's not on our strong acid category. So this is going to be a weak acid. And looking back at the anion and the cations that form here, my strong base is going to have a weak acid here, so it's not going to react in water. And then my weak acid is going to be making a strong conjugate base. So I know that this solution here is basic. My cesium iodide here, if you were to break this one up. So cesium is +1, iodine is -1, and cesium, same deal as what we've talked about before. It's a group 1 metal, and you know that when it turns into a base, it's going to turn into a strong base here. My iodine, when it turns into an acid, we have HI, and we talked about today that this is going to be a strong acid. And if you have strong acids and strong bases, what we did up here, their conjugates are going to be weak and weak. So there's going to have no reaction in the water. So this is going to be weak conjugate acids, and you have a weak conjugate base. And basically these guys here, your cesium plus and your iodine negative, they're not going to do anything with the water. So we end up just getting a neutral reaction. Okay. And then finally, if we look at our very last problem, we have Mg plus 2 HCOO -1 charge, and my magnesium is going to pick up MgOH2. I know that this is going to be a weak base. Remember, magnesium and beryllium, they're in the group 2 category, but they're not a part of the strong base side. And then if you take this and you take your HCOOH, this is not on my strong acid category, so this is going to function as a weak acid here. Now, this was that very, very last category that we talked about in class. If you end up getting a weak base and a weak acid, the conjugates, like the Mg plus 2, it has to be a strong conjugate acid. And my HCOO negative, this is going to be a strong conjugate base. So the question is, which one wins out? Is the solution going to be acidic or is it going to be basic? And in order to figure out a problem like this, you would actually have to use a little bit more information. You would have to look at your Ka and your Kb values. So let's say here we looked up some Kb's and your Kas, and in the problem you were told a few things. You were told that the Ka for magnesium, or your Kb, I'm sorry, because that's a base. So your Kb of magnesium hydroxide is 1.0 times 10 to the -9. And let's say that you were also told that the Ka for your HCOOH was 1.8 times 10 to the -4. So remember here that this and this, what is given to you maybe in the problem, this is what this and this is, right? But you actually need to figure out what the Kb and the Ka would be for the actual ions that we have that the salt is going to break up into, right? So we're not trying to look at the conjugate acids or the conjugate bases, but I just want to see what are the Kb's and the Kas here. So you could take what they gave you, and I could solve for the Ka of Mg plus 2 by just taking my 1 times 10 to the -14 and then dividing it out by 1.0 times 10 to the -9. And the same thing here, I don't really want to know the HCOOH. I want to know what the HCOO negative is, because these are my actual cations and the anions. And I'm going to figure out what the Kb of that is of the HCOO negative. And the same thing that I said, we're just going to take your 1 times 10 to the negative 14 and divide it out by whatever they gave you as your Ka or Kb, because it's just the opposite of that. So my first one, you're just going to take that and divide by 1 times 10 to the negative 9. And you would end up with 1 times 10 to the negative 5 here. And then same deal, so 1 times 10 to the negative 14. And I'm going to divide that by my 1.8 times 10 to the negative 4. And my Kb would come out to 5.5 times 10 to the negative 11. And at this point, all you're doing is you're comparing. Which is a bigger number? Is it my base dissociation constant or is it my acid dissociation constant? And in our case, we have 10 to the negative 5 is much bigger than 10 to the negative 11. So my Kb is bigger than my Ka here, according to these numbers that we just solved for. And this tells us that the solution itself is going to be basic. Okay, so this problem was a little bit more work, but it just gives you guys a good idea in terms of figuring out that if they're both going to be forming a strong acid and a strong base as the conjugates, then you really need the Kb's and the Kas to figure it out. And sometimes the Kb's and the Kas given, you have to change it back to whatever the Ka or the Kb would be for the actual anion cation, which is what the salt would break up into, which is why we had to do that extra step. And then finally, you just go through and you compare it to see which one wins out. Is it the base or is it the acid there? And that's all.